Are we ready? Kinda. Any quick last minute exchanges, gossip? We have a new chancellor, we have a new provost. Not that you really care. More important for me than for you, but this is always exciting. Half the class is here. I always wonder why that is, but then they trickle in, the first 20 minutes of the class. So welcome back. This is IES 106. The university has this new thing, which is really fantastic, and I wish we would have had this when I was starting here in the late 1800s, where if you're a new assistant professor, you can come in and you can observe people who won teaching awards teach. So I did win a teaching award at some point. I don't know why, but I did. So thank you. It also came with a monetary reward that really came at exactly the right time because I was really broke. So we have a guest today from the political science department, so I have to be on my best behavior. All right. So if you're thinking I'm even more boring than I usually am, there's a reason for it. The other quick announcement is I have this new thing. It's a tablet that I can draw on. I spend all weekends. My son's into fighter jets right now, drawing fighter jets on this thing. So I'm getting there in terms of drawing live. But the nice thing about that is on iTunes U, you can watch lectures. So if I draw on the board, you don't know what's going on. But now what in theory this does on iTunes U, you can hear my voice and see me draw live on the screen, which is if you don't understand something, you can watch the actual lecture again. So let's see how this goes. In about 3 weeks, I'll ask you how it's going. And if you hate it, we'll go back to chalk. All right. Just to make sure we're on the same page. What we talked about last time is something called indifference curves, right? We're all agreeing now that most people's preferences are complete, transitive, and non-satiable, meaning you can rank bundles. If bundle A is preferred to bundle B and bundle B is preferred to bundle C, transitivity implies that bundle A is automatically preferred to bundle C. And more is better, or non-satiation implies that you always prefer more of something to less of something. What this implies, these three properties on your tastes, not everybody has the same tastes. I don't like Celine Dion, you may, right? But the point here is what this implies about these indifference curves, these curves that map out in a space of Hershey's on the x-axis and Reese's on the y-axis, or whatever good you want to think about. It maps out these locations of bundles that you're indifferent between. And these bundles that you're indifferent between, we call indifference curves. And these three properties of preferences that we assumed imply that indifference curves cannot cross. They cannot be fat or thick, and they cannot be upward sloping, right? So indifference curves are downward sloping, they're thin, and they never cross. So if you draw me any of those three, I take away all your points from the midterm, right? If that's not enough motivation. Not the midterm, just that question. I'm not that mean. We also discussed different types of indifference curves. We looked at imperfect substitutes, which are those nice sort of bowl-shaped indifference curves where the marginal rate of substitution varies along an indifference curve, and we'll think about this a little bit more today. We talked about goods that could be perfect substitutes, Arrowhead and Dasani in 16-ounce bottles to Max are perfect substitutes. The indifference curves are straight lines with a constant slope, which means the marginal rate of substitution, the rate at which I'm willing to substitute between Arrowhead and Dasani is constant along a given indifference curve. And we talked about perfect complements, coffee and cream, ketchup, French fries. My son will only eat fish fingers if they're wedged between two slices of cucumbers. So, it's some people like certain goods in complements. I like each pair of shoes accompanied by 2 shoelaces. I don't believe in Velcro, okay? So the point here is this is where we were at with indifference curves. And at the end, that sort of happened rather quickly, and there was this thing where Max all of a sudden rose out of the corner like Batman, a German, very non-sporty, non-threatening version of Batman, but still entertaining, I hoped. What we said is, well, each bundle, each combination of Reese's and Hershey's can be, you can value by meditation how much you like that particular bundle relative to others. So mathematicians are not especially good at meditation. Economists even worse. So what we've done is we've instead said, well, each bundle can be associated with a level of utility which we can measure in a certain type of unit. That unit is called a util. So I can rank different bundles, different combinations of Hershey's and Reese's. And if this here is, what do we have here, Hershey's? We have Reese's here. I can sort of walk around, and we agree that as I walk around on this Cartesian plane, and I do the hustle, right? What I'm doing is I'm essentially mapping out different bundles of Reese's and Hershey's. And at each level, each combination of Reese's and Hershey's here, I could stand for 30 seconds, I could meditate and think about how much I like that bundle, and then translate that in a numeric value, which is utility. Utility itself is not a cardinal measure, it's just a ranking measure. So the utility of this bundle right here is higher than the one right next door that has fewer Hershey's. The utility here, the number of utils I get from that bundle, is higher than the number of utils from that bundle. So I could walk around all possible bundles of Hershey's and Reese's. I start with 0 utility here, and as I map out the utility that comes as I get more of both goods and more of one good and more of another, that surface looks sort of like a soccer ball if you cut it into eighths and stuck that eighths into a corner. I will show you that using MATLAB in a second. What that defines is a so-called mountain of utility, right? A three-dimensional function that is pretty neat. I can't draw in 3D by hand. I actually can, but you'd be so intimidated that you'd all run away screaming in awe. The point here is I like 2D things. So what I'm going to show you today, again, is that this nice mountain of utility, I can look at paths along that mountain of utility that is the same distance from the ground, meaning that gives me the same level of utility. And if on that path, as I walk around that level of utility on my utility function, if I looked down, I could tell you exactly the set of bundles that going straight down give me the same level of utility. So if I slice that mountain at one level and I look at the edge that's left, that's a set of bundles that give me the same level of utility, the same level of happiness, or I'm indifferent between these bundles. So that's going to have something to do with an indifference curve. Now, before I show that to you, and I'm going to have to switch computers because I don't have MATLAB on this new thing here, let me show you again what we said last time. Right? We know mountains. We don't know mountains of utility yet, but we know mountains of rocks and other stuff. I don't know what's on the inside of mountains. Chocolate, maybe. Never been there. You don't know either. You haven't been there. So the point is, this is a mountain, right? And I could look at it, and if I wanted to figure out which sort of height level here gives me the same level of altitude along the mountain, I could simply use real science and draw lines that give me same levels of altitude along the mountain. This is not a high-res picture, but you can sort of see that here there are lines that tell you same levels of altitude, and the difference here, the increments I think are 100 feet or maybe 100 meters or something like that. Gotta be 100 meters. Now that's not a really convenient way to look at it. When you go hiking, you don't carry 3D maps in your backpack, right? Terribly inconvenient. Even though it'd be kind of cool if you're out there in Yosemite and all of a sudden you draw a to-scale model of Yosemite out of your backpack. What you draw around is pieces of paper that look like this. It's a 2D representation of the exact same information, and I would argue it's more useful. These topographical lines here, or this topographical map, shows you here at 7,500 meters, right? The entire world is metric except for this place. 8,000 meters, really high. It tells you the difference between each of these two lines tell you 100 meters in altitude. Right? So if the lines are really close together, do you want to climb up there? No, really stressful, really steep. If the lines are really far apart, that gives you a lot of horizontal distance to climb the same amount of altitude here. So all the information you really need about the mountain is summarized in this nice 2D picture here. So Max, I didn't come here to learn stuff I already knew. I'm a proud member of REI. I have hiked the world's mountains, swam the world's oceans, and surfed the scariest waves, all the while writing an honors thesis, getting a 4.3 GPA, and running the ASUC. I know what you kids do in your free time. So, come on. Whoa. I'm excited to get to share this with you. So what is this thing? That's a utility function, all right? This is a utility function that here has the origin, 0 Hershey's, 0 Reese's. Over here along this axis, the number of Reese's increases from 0 to 30. Over here, the number of Hershey's increases from 0 to 30. And if I sort of walked straight ahead, I would add, equivalent amounts of Reese's and Hershey's at a time. What this surface here tells me is how much utility, this is Max's utility function. This took me, I was at Green Gulch all weekend meditating about this utility function, and I mapped it out. So this is what my utility function for Hershey's and Reese's looks like. Pretty neat. Well, Max, anybody can draw a 3D picture, I know, but can you do this? Are you ready for this? Whoa. I can turn this 3D function around in MATLAB, and I'm just looking at it from the other side, right? Now I'm standing at the 30 point, and I'm looking towards the origin, and what I'm seeing here is these lines on the ground. What I've done here is, through fantastic MATLAB code that I'm very proud of, is I've essentially taken a camera, and I've done this slicing thing where I slice the utility function at 10 units, at 20 units, at 30 units, and I've projected that edge of the utility function onto the ground. What do these things look like? They look like indifference curves, right? So the beautiful thing here is that all indifference curves are essentially, if you take a slice of the utility function along, let's say, 10 utils, right? You cut it off with a really sharp knife, what you would get is sort of a round, sort of part of a roundish surface. And then if you looked right up at the utility function from the top and you took a crayon and you sort of traced out what that thing would look like on the surface, that would give you an indifference curve. It would trace out all the bundles that give you the exact same level of utility. Another way of saying that, all the bundles that you are indifferent between, or it gives you indifference curves. So if you actually did that and you looked down on the ground from above, for this 3D utility function, right? Now I'm just looking from the top down at the different bundles of Reese's and Hershey's. For this particular utility function, this is what the indifference curves look like. Of course, there's an indifference curve through every point, so I've just chosen to map 5 of them for demonstration, but you could draw them anywhere you want. So the cool thing about this, all I've done here is I've really taken this sort of 3 simple assumptions, which I think are very reasonable about your tastes and preferences. I have told you what that means for indifference curves, what completeness, transitivity, and non-satiation mean for the properties of indifference curves. And then I've arbitrarily, in some sense, but not very much so, simply mapped your preferences for bundles into a mathematical ordinal expression for happiness, right? Can you trade utils amongst each other? No, right? If you sit at Thanksgiving and say, or the next holiday dinner, and you say, Grandma, this Christmas or this Passover, I brought you a bag of utils. She'd be like, son, we're spending your money not very wisely. You should have gone to Stanford, right? Utils are not a tradable commodity. They're simply an indicator of happiness. If I'm telling you right now that 2 Hershey's and 2 Reese's give me 20 utils, Walter, how many utils do 2 Hershey's and 2 Reese's give you? So does that mean that Walter is happier than I am from consuming the same bundle? No, right? All these utils allow you to do is to rank bundles for yourself. I like 2-2 better than 1-1. I like 3-3 better than 2-2. But the number of utils simply allow you a ranking for one individual as to how much that individual prefers certain bundles over others. It's an ordinal measure. It does not allow a direct comparison of the level of happiness across individuals. It's just an aid to help you rank bundles, all right? One thing about economics classes that gets people all the time is, Max is standing up here and he's sort of babbling and he's got cool pictures and we've already had our first whoa moments. That's pretty exciting. And this all makes sense to you right now, roughly. You go home and it still makes sense and you feel happy and you sort of, lock it away and you move on to your engineering or math class that seems more terrifying, and then by the time it comes to the exam, you assume that you'd understood it and you try and regurgitate this material and you can't. It seems logical. It seems to make sense here. But as soon as you go home and you try and explain this again to yourself, you're going to start getting a little bit confused. So I'm really trying to encourage you very strongly, especially at the beginning, since every single lecture builds on the next one, to please keep up with the readings and flag things that don't make intuitive sense to you and come see us, your lovely GSIs and myself. I had 0 visitors in office hours last week. I got a lot of work done, but I'd rather have chatted with you because I didn't like what I was doing. So please keep up with this stuff. If it makes sense in lecture, that doesn't mean at all that you understood it, and the worst point in time to find out that you really didn't understand it is the first midterm, all right? I forecast at least 20 people in tears in my office after the first midterm. It happens every year, and the most frequent word I get is, I'm so sorry, I should have read more like you said in lecture 4. Okay, I sound terrible. I can already tell. I sound like my own dad, who's a nice man, but is this it? Oh, man. Okay, new technology here. Yes, I want this. I warned you that this could potentially go. Oh, hold on, somebody showed me. Okay, view, single page. Ooh. How are you doing? I'm not doing so great right now. Ooh. Let's try that again. View, single page. Whatever, this is good enough. I don't know what's going on right now with this thing. It should give me more picture. Okay, so we're happy how utility is just a measure of happiness that we've constructed. So I'm about to introduce something else. In economics, you'll hear the word marginal a lot, right? For those of you who've taken calculus and love calculus, marginal, you realize, is just the first partial derivative of something in most cases, and the same thing is true in economics. But one of the most important concepts, and you will see why this is so important today, is the concept of marginal utility. So the overall level of happiness is really fundamentally not that interesting to me. What's really interesting to me is a concept known as marginal utility. What marginal utility tells me is how much additional utility I get from consuming 1 more unit So this means, let's say I'm currently consuming 2 Reese's and 2 Hershey's. If you give me 1 more Hershey's, how much does my utility go up by? All right? So it's the change in utility from consuming 1 more of one of the units, holding everything else in the world constant. This is something that I took Latin for 9 years. I don't know why. The only 2 words I use are, the Americans say ceteris paribus, holding everything else constant. Right? So here what I'm arguing is marginal utility is, in math terms, the first partial derivative of the utility function with respect to whatever good you're looking at. Since you're not required to have taken calculus, all it means is how much does your utility, your level of happiness, change by if I give you 1 more unit of Reese's in this case. So if your utility before was 10 units, I give you 1 more Reese's, and your utility now is 12 units. What's your marginal utility of Reese's, of getting that 1 more Reese's? If you don't see so well, I have 2 fingers up in the air, so the answer is 2. All right, 12 minus 10 is 2. We'll do an example. Now, the important thing here is marginal utility holds everything else fixed. People get this confused all the time, and they think, well, we live in the social science sort of world, which is not a system that lends itself to study in the lab, where you can really hold the entire world constant and just change one single dimension here. But everything changes all the time. Well, this is unfortunately, and also fortunately for me, because that's why I have a job, the reason why social sciences are so hard. We're studying a system where nothing else is ever really constant. So the thought experiment here is if you could freeze the world and just give that person 1 more Reese's, how much would their happiness go up by? All right? That's what marginal utility is. So I've come up with these beautiful new slides. Hopefully this will work. Since this projector now is projecting a little bit small, unfortunately the scale isn't great here. But what I want to do is, for Max, let's say he's consuming, he has 2 Hershey's in his bag, okay? I have those. And I want to know what happens to my level of utility as I go from 0 Reese's to 1 Reese to 2 to 3 to 4 to 5 to 6. So I've asked myself that question, and I like to have a little bit of Reese's with my Hershey's. I need some peanut butter in there somewhere, all right? So unless you give me some Reese's, I'm not going to have any utility. So at 0 Reese's, I have 0 units of utility. At 1 Reese, I have 25 utils of utility. So I like having 1 Reese much more than I like 0 Reese's. At 2 Reese's, I have 40 utils of utility. At 3, 50. At 4, 56. At 5, 60. At 6, 62. So what are you doing with this amazing information, Max? I'm going to plot it, all right? Come on, new technology. Don't fail me now. Okay. So what we've got is we start at 0, okay? And we look at our table. At 1 Reese's, the utility goes up to 25 units. So my second point is here. At 2, it's 40. So that point is here. At 3, it's 50. So right here. At 4, it's 56. And then at 5, it's 60. Is that right? You can always yell out stuff in my class. Totally fine. And at 6, it's 62. Okay? So I've just plotted these points that I had in the table. And I can, of course, connect these because I could do this experiment for multiple, for partial Reese's. Ooh. Wow, this is harder than I thought. But that looks okay. I don't know if I could have done better with chalk. But this is what the utility function looks like, right? It maps the level of happiness from each unit of Reese's I get. This is getting worse. Oh. I'm so sorry. I'm going to bring you a lot of chocolate next time. I have to master this technology still a little bit. But what this tells me is the overall level of utility as a function of Reese's. In the back, I'm holding constant that I have 2 Hershey's in my bag. So I'm holding the number of Hershey's constant. What I'm interested in, however, is how much additional utility do I get out of each additional unit of Reese's holding Hershey's constant. So as I go from 0 to 1 unit of Reese's, my utility goes from 0 to 25. So the marginal utility of getting 1 more Reese's at the origin from having 0 to 1 is 25 minus 0, right? So the marginal utility, the increase or change in Reese's. Hold on. Here we go. This thing is amazing. Maybe to you this is so 1999, but to me this is so 2020. Okay, so the marginal utility would go from 0 to 25 is 25. Now I have 1 Reese's. If I give this guy 1 more Reese's, I go from 1 to 2. The utility goes not from 0 to 40, but he's already had 1. He had 25 utils. It goes from 25 to 40, so marginal utility is 40 minus 25. It's 15. When I go from 2 to 3, it goes again not from 0 to 50, but it goes from 40 to 50, so the marginal utility is 10. And we could continue doing this 6, 4, 2. Okay, terrible handwriting. My 5-year-old is better than me. So marginal utility here is 25, 15, 10, 6, 4, 2. What are you realizing about these numbers? Are they getting bigger? Are they getting smaller? So imagine that day. It's week 14. Actually, it's week 16. You finished your last final at Cal. All right? You're done. You're tired. All right? You're really, really, really exhausted. You're really thirsty. You're German like me. You head into, well, Rally's doesn't exist anymore. I guess Jupiter's. And you go and buy a beer, right? And you sit there and you drink it. How much utility does that beer give you? Oh, a lot. Let's say, same thing goes if you don't like beer. You're a runner. You get your first 16-ounce glass of water. That feels pretty good. I order a second beer. Does that second beer make me happier? Yeah. But does it give me the same amount of additional satisfaction as that first one? Not quite, right? I'm happier. But that first beer after being exhausted, or that first glass of water after running, or that first handful of popcorn when you get to the movies, it just gives you so much more additional happiness than the second one, right? The second one still makes you happier, but the change in your happiness is just a little bit less than the change you had from the first unit. If I have the 3rd beer, the 4th beer, the 5th beer, or the 5th, 6th, 7th glass of water, you're still feeling pretty good, but overall, the additional level of happiness you get diminishes. So what you're seeing here is that the marginal utility, meaning the change in happiness, as I add more Reese's to this individual, Max, here we go. If I map this now, right, I go from, at 1 unit, 25, 15, 10. So 25 at 1. 15 at 2, 10 at 3. I think it's 6 at 4. Is that right? 6, 4, 2 it was. 6, 4, 2. So if I connect these dots, that marginal utility curve looks something like this. Okay? I think that looks pretty cool. So what we're seeing here is overall level of happiness goes up if I give you more